So, ladies and gentlemen, welcome to Go to 10. How many have been here before? Okay, I don't need to say that much. My name is Christopher Cameron. I work at Linköping Science Park and here at Internet Foundation and Go to 10. I work with events and connecting people. I'm one of the community managers here at Go to 10. My colleague Uli is right over there. So if you have any questions, you can come to us after the show today. But just a little quick thing about what Go to 10 is. It's a meeting place. It's a place where you can go hang out by yourself. If you don't like your colleagues, we have office space for you here for free. You can come and be alone. If you like your colleagues, you can also bring your colleagues here. We have a meeting room, pod studio, and you can do events like we do today. So come and talk about everything with us after the show today. Also, a big welcome to all the people out there in cyberspace. We have about 10 people watching out there today, so we will be looking at them. But I'm not the one to talk today. I have two colleagues from the Science Park that will take the microphone. And of course, we have our special guest, but a little more about that later on. So now I'll give the microphone to Maya.
Thank you so much, Chris. Yes. So my name is Maya, and this is Julia, and we work at the Linköping Science Park.
Yeah, and very welcome to this edition of Tech Tuesday that we do in the light of International Women's Day. And this week we're actually taking the moment to just highlight inclusiveness in tech, because there's been a progress, but the reality is that women and underrepresented groups are still a minority, especially in leadership and innovation. And diversity isn't just about fairness. It creates stronger teams and more sustainable solutions. And at the same time, DEI efforts are being rolled back in many places. So that's why it's important to not just talk about this stuff, but to also take action. And that's why we're so happy to today highlight those companies working for more inclusive tech. So today we will get to listen to Erica Johnson, professor of gender and society at Linköping University, and Sagi Haji Sharif, PhD in computer science, and they're both founders of Fair AI Data. But before we get to listen to them, Maya and I are just going to take 1 minute to explain East Sweden Tech Women.
Yes. So East Sweden Tech Women is a network that is run by us at Linköping Science Park. And what we do is that we are a network for women and non-binary professionals and students within the tech industry. And we create events like these and other activities and create meeting places. And we go from soft values to innovations and technologies. And within our activities, we have a very wide range of what we talk about and do, like anything from AI to game development.
And here are just some pictures of examples of what we've done so far. We have arranged study visits to Actia and Beyond Gravity, for example. We've had lunch lectures on programming. We've discussed diversity at the workplace. So just to show you, there's nothing that's too small or too big to do. Just we want to connect women within from different tech sectors, no matter of age, to boost their careers.
Yes, and on your seats today we left a small gift. It's a book that we at Linköping Science Park has published. It's called Invisible Participation, and it is about the relationship between equality and entrepreneurship. So it's a popular version of a study made by a researcher called Matilda Eriksson, where she has talked to women who are married to or live with entrepreneurs, to male entrepreneurs. And so it's very good reading, very interesting. And I think these are in Swedish. If you want one in English, just grab one of us afterwards and we will exchange it for you. And you can also download it, like on our website, if you want to spread it to more colleagues or friends.
Yeah. So that was short about us. You can see our contact information here, because if you want to collaborate or arrange something with us, don't hesitate to contact us. And we also have a group on LinkedIn that you are very free to join. You can scan the QR code and we could also send it out afterwards. But now I think we have talked enough. So now the stage is yours.
Thank you. Thank you. Just do the quick computer switch here, and hopefully thank you for coming. International Women's Day coming up, but we're really glad to be here on a Tech Tuesday. I had not expected it to be so many women. Super great. Also, really happy for the people who aren't women who are here as well. Also great and welcome. Glad that you guys are here. We're going to talk about how to shape a more inclusive future with AI and synthetic data. So we're going to go deep on you here, but maybe just a couple of quick statistics and thoughts that we want to talk about. That is usually the reason that as a professor of gender studies, I get invited to talk at tech areas, and that I'm teaching over at the tech faculty at the university. And that is that in Sweden and in Europe and in North America, in the North and the West, we have a significant underrepresentation of women in the tech industry. These statistics vary from country to country, and they vary a little bit from which part of tech we're talking about. If we're talking about like education, if we're talking about certain parts of the education systems, where in the companies people are working. If people are running their own spin-offs, then the numbers are even lower. If you're publishing articles, who's the main author? All of these numbers vary, but they rarely get above 20%, and they're often closer to the 10% in European countries and North America. But this is a historical and cultural anomaly. There are large parts of the world whereas that's not the case, where there are lots of women working in tech. And up until the 1960s and 70s in Europe and in North America, there were lots of women working in tech. So there are lots of reasons why this has changed here in Europe. We're not going to go into that today, but it's very interesting. What we are going to use as a background is a couple of assertions from the research that shows that technology is gendered by association. So who's already working in it helps us imagine who could be working with it. And technology is gendered by design. And that's actually really relevant because the people who are working with it bring their own understandings and cultural expectations of the world and put it into technology design. And it ends up creating feedback loops. So having a very, very unevenly distributed tech field like this is going to impact what sort of technologies we end up having. One simple example of how this can be the case is that we see that there are 327 million fewer women who have a smartphone than men, which means there are also 327 million female data points that are creating data that's then being fed into all of the algorithms that are producing the world through the smartphone use than men. So it means we've also got really, really different representation in the data mining or data extractivism, and that we're then creating and entrenching the inequalities that that type of uneven distribution makes. So we're repeating, we're amplifying, and we're not getting away from uneven distribution already with simple smartphones. But there's more to it than that.
Thank you.
Yeah.
Yeah, so the problem that Erika mentioned, we can see it in different aspects of data as well. So the real data, we are using it to train our machine learning algorithms, but there are some challenges with it. Not all scenarios we can capture. There are rare scenarios that we are missing, the missing values, why we couldn't collect some attributes, for example. The access to some scenarios like different weather condition, camera blur, and so on can affect the imbalance in the data. And also producing labels is very difficult and intensive work, and there would be mistakes also in the label. And all of this can lead to a risk of bias in the data, and this bias can be propagated into our models as well. So let's talk about the overgeneralization. The overgeneralization comes from the fact that if we have a population that is overrepresented, then the machine learning algorithms gets this interpretation bias where it can think that the decision that is valid for the majority should apply for every subgroups in the population as well. So if we have a population with more lighter skin color, the facial recognition algorithm would think that the features are that, and would try to apply it for different subgroups as well, which leads to error in the machine learning, and leads to the fact that we have we don't have pointer here, no? We have a much higher error for example, darker females compared to lighter males. And let's imagine this scenario that we have these images, and for whatever reason, it's been corrupted with noise, with downsampling, and we have lost some information. And we train our model to be able to upsample and reconstruct this image to get back this original one, but instead we get this one, because one population is overrepresented in the data. Then the facial features are more towards that population. And they analyze this algorithm Pulse, which is a generative model, and they call this white Obama because Obama's facial feature has changed. And here we see that if we consider this diversity that we have in the data and underrepresentation of some subgroups, we can get a better reconstruction that is more fair for different groups in our data set. So we have this problem with real data that because of different scenarios, we can lack information in it and lead to biases. So then it comes synthetic data. Synthetic data, here we mean the data sets that is generated to represents the statistics of the real world based on, of course, the data that we are using. And it's generated using different models with learning the probabilities explicitly, implicitly, or with autoregressive models to generate the synthetic model, and then we can use it in different applications for training the model, to augment the data better, to be able to create an example of a real data without sharing the data, so that we can test the different models with different algorithms, and so on. So it has it came to be as an addition to the real data, and it can be the different formats. We can be tables, tabular data. It could be images with different semantic segmentations, textual, or time series data. And it has been used successfully in a lot of domains, like medical domain, for improving the performance of the model. In the medical domain, it has been used mainly for data augmentation and to diversify the data. And it's also being used because of the privacy issue, so that the patient's information doesn't leak into the different places. So it has been used for privacy, and it has been shown to improve the performance of the segmentation in this example to 2.5 to 4%. But this is an overall performance gain. We have to still go and see what it does to different subgroups, of course.
Yeah. So here we've taken you in 15 minutes 10, actually. We've taken you from thinking about the fact that there's underrepresentation of women in the tech industry and the tech field in the North and in the West, and talked about how that can impact both who's being allowed to work in the field, what sort of salaries they're getting, what sort of distribution of resources we're giving to different types of people in our collectives. But we're then also saying that this can impact what sort of technologies are being developed. Then we made a pretty big jump into going right into synthetic data and the way that our developing those technologies and who's represented in the data can impact the data that's going to be used for developing it. And we jumped over to synthetic data specifically to talk about how, okay, the fact that we maybe have a real data that has weird distributions in it, could be a weird distribution of women versus men, could be a weird distribution of different types of ethnicities in that data, could be, and most likely is, intersectional aspects of both of those and more. Or it could be simply something like whether or not we have leaves or pine needles on the trees that we're measuring. In actuality, it doesn't really matter. What we're talking about is that we have a world that when we try to put it into a computer or digital way of knowing it is flattened ontologically, and we collect the data about that world in ways that are not going to represent everything about that world in it. We're going to be making cuts and excluding things from it, and we're going to have in that data that we've collected about the world a distribution that maybe is shaped like a bell curve, but in any case is probably going to have more of some things and less of other things. And when we start to do stuff with that data, like produce synthetic data from it, or run a bunch of machine learning algorithms on it, we're going to recreate that distribution and maybe even change it. And as that happens, we end up getting problems. Things like mode collapse. So for example, we see that there are, it can happen that when you reproduce that distribution, you end up losing your edge cases. Or we can have model collapse, where we're amplifying the norm, the normal, reproducing what is a lot in that data already. And that's going to change the way our machine learning, our AI models recognize and think about it. And we're going to be getting intersectional hallucinations and also intersectional fidelities, which I'll talk about in a second, or maybe now, actually. Right. So these were questions that I started thinking about a lot when I was coming to the concept of synthetic data a couple of years ago as a person who works in the medical humanities and is concerned about gender. And I started hearing medical doctors talk about how it's going to be great with synthetic data because we can reproduce population data without having to worry about exposing our patients and revealing privacy. But then I also heard in other bubbles, some of which Sagi was in, that actually, well, you know, when you do these sort of things, you're going to be amplifying the norm and minimizing the edge cases, and thinking that, well, actually, we all know that in medical data today, we have a very small representation of female bodies and a huge overrepresentation of male bodies. So if we're going to be reproducing this, you know, a few iterations in, we're going to end up with only male bodies in the medical data. And I didn't think that was a great idea. So Sagi and I started working on these questions and just running some experiments. So for example, Sagi took the 1990 US Census data, which is an open access data set. Lots of people use it. People understand what it is, and produced some different versions of synthetic data using different models on it. And we saw that, just like was expected, edge cases started disappearing. Things that were very smallly represented in the data originally disappeared completely in the synthetic data. But also, weird things started happening in the relations between attributes, in the correlations between the parts of the data. So here, I won't explain it all, but you can see the real data and the synthetic data and a visual representation of country of origin, age and educational level. No, educational level and gender. And you can see that the synthetic data is very different than the real data. So we started to look at that even more closely to figure out what it was. And now you're going to freak out and be like, oh my God, what is this SPLOM? What is the SPLOM? And I'm going to tell you that it's a SPLOM that Sagi made that represents 3-point intersections of the population data, 1990 US Census data, in the real, and up here, the synthetic. The diagonal in the middle is the correlation between the real and the synthetic at the single attribute level. So here we have age, and you can see that the brown overlap is the correlation, and it follows the statistical representation in the real data fairly well. It's not identical, but it follows it fairly well, which is good, because if it was identical, it wouldn't be synthetic data. Then we would have a problem. So it has to be different, but it's different in a good, sort of close way. Then, since I work in gender studies, I was like, oh, what about the intersectional level of it? And so we looked, and here, for example, we have the intersection of age, income, and gender in the real and the synthetic. And we can see here, too, gender being pink, blue on the screen, income being high, low, a binary, and age along the bottom. We can see that at this 3-point intersection, the synthetic data is fairly representative too. Slightly different, which is good, otherwise it wouldn't be synthetic data, but fairly good. Then we look down here, occupation, marital status, and gender, and notice that there was an awful lot more pink in the synthetic data. And when you went in and looked at it more closely, Sagi, you saw that there was one female husband in the real data, 1990 US Census data. So either somebody wrote this in by hand or it was just a data entry problem, we don't know. And in the synthetic data, we had 259 female husbands, which today and in some countries, totally fine. But if we're trying to synthesize the 1990 data and represent it, this is the problem. We also had 333 points that were husband, wife, and single. So obviously something that can't be, right? So these are what we were calling intersectional hallucinations. But these are what we are calling intersectional fidelities. And one of the things that we're trying to do with the research that we work with and the company that we're working with is bring to the vocabulary around synthetic data the idea that you have to really think closely about what sort of intersectional fidelities you have and what sort of intersectional hallucinations you have if you're going to in any way think that you can use this data for anything other than your original research question, and probably also your original research question. But Sagi, being the engineer that you are, it was like, oh, well, that's interesting, Erica, but we have to do something else too. We can do it better. And then you produced new synthetic data using a diffusion model instead of a GAN. So the first one was made with CT-GAN. And you got to the point where it wasn't at all as large a discrepancy. So there was still a bit of a hallucination, but not at all as large, which is also another lesson learned, right? That there will always be hallucinations and fidelities, especially at the intersectional level, at the attribute level. But you have to know where they are and how many, and you have to be able to curate for them. So like a good machine learning expert could do that. But if you're just going to put your data up into some sort of website that's going to produce synthetic data for you, how are you going to know that you're actually curating for the types of fidelities you need and allowing the types of hallucinations that aren't going to be relevant for your question? This also, I think, does something to our dream of having open science and open access to all sorts of synthetic data that could just be produced and put up into a cloud. Now I feel like a boomer talking about the cloud up there, but put up into the cloud and then downloaded for lots of other questions. Because actually what we need to know is how that synthetic data is representing and misrepresenting the world that it was actually supposed to be modeled based on. Because it always will be, and that's part of the point of synthetic data. In fact, as Sagi keeps reminding me, it's part of the good thing about synthetic data, is that it adds new dimensions and new information to the data. But where those are in the data is extremely relevant to how we use it. So one of the things that we're working with in our company is talking about how we need a vocabulary and guardrails for transparency about these things, and working with data repositories to set up regulations or at least suggestions for types of readmes and metadata information around synthetic data, so that the synthetic data that's being produced and shared can actually be done so in a transparent and reliable and reproducible way. Here's just a final example that I want to give from a Swedish case that we've been working with the SCB's data. Sweden in numbers. This is this is actually taken from a display, an exhibition at the Visualization Center in Norrköping, where they have visualized the Swedish population data. And you can ask this visualization questions like, for example, where in Sweden do we have the most people with a university degree? Answer, Stockholm. And using this interface, you can explore and see, like, what does that mean in terms of their salaries, their gender, their age distribution? How is that related to other aspects of the population? Then Sagi took that data and synthesized it a couple of different times got different types of synthetic data, as you always will do, and then exported one of those in aggregate, and we visualized it. And then we asked the same question: where in Sweden do we have the people with the most people with a university degree? And the answer was Östergötland, which, you know, personally I think is really great, but not necessarily does it correlate with the actual SCB data. And these types of intersectional hallucinations are extremely relevant if we're thinking that we can use synthetic data to then be the basis for social policy decisions, decisions about like all sorts of things. We have to know where the hallucinations are occurring if we want to know what we can use that data for. Let's see, I think yours was that one, yeah.
So what Erika mostly talked about was the problem with mode collapse, that we are losing some dimensions of the data, some categories. But then there's a problem with model collapse. What I'm going to talk about here is exaggeration, just to get the idea what we mean by model collapse. So imagine we have a data set of different breeds of dogs in real life, and then we want to train a model to generate the same structure as the first picture. And then because now we have golden retriever overrepresented, we get this overrepresentation in the first round of when we are generating the synthetic data. And if we continue and use this one now as an input to the model to generate the same, to learn from this one and generate data, then we get more overrepresentation of golden retriever until the point that it just learns golden retrievers and forgets about the other varieties. And if we continue and continue, at some point the model forgets what was the real distribution of the data and just produces the mean. And of course, this is an exaggeration. The article you can read about it is called AI produces gibberish when trained on too much AI-generated data. This is a bit exaggeration because in real life we don't use the same model and exactly the same data to do this training. But it points to an important fact that we need to be sure that the data is diverse enough so that we don't end up with this problem. If the world goes on with just using the synthetic data without looking at the diversity and structures of different subpopulations, we could end up to a problem close to here. So it's very important to have that in mind. And there are some approaches for algorithmic fairness so that we can try to improve our data, our models. One of them is looking at it from bias mitigation, where we start with a bias model, we start with a biased data set, and we try to remove what was the problematic signal, what was the problematic part of the model, and try to remove that to reduce the bias along specific axes and improve the fairness. The other approach would be inclusion, and we start with underrepresented data, and we try to add signal to our data, to our model, to try to improve the representativeness of those underrepresented. And that can also lead to increasing the performance. So removal and inclusion of signal, two different approaches, but both are very necessary to improve our algorithms, basically.
Right, so a few suggestions that we think, aside from trying to educate and hire more women, which I guess we're supposed to say on this type of event, but also think about how that impacts your data, and think about how the types of things that we know about inclusion, even from the real world, are very relevant for your data world. So know things like your edge cases. You are always going to have edge cases in your data. There are many cases where your edge cases in the data do not actually represent edge cases in the world. They're just in your data. So know why they're edge cases in your data. Know the relationships that your data contain. If you're looking at something like, to make it easy and understandable, I don't know, gender and salary level, then we see a relationship there. But you can't change that relationship by just adding more of the gender or raising that the income of those genders in your data, and actually produce a data that will address the problems, because this relationship is not one-to-one, and it's not based on a simple correlation between gender and income. It's based on things like how we assign value in society in many different ways, and whom we think has that value. Once you know your own data and the relationships in it and how intricate they actually are, think about how those are actually being reproduced in your synthetic data. Are your edge cases still there? Are you creating new hallucinations that weren't there in the first place? Is it going to be okay? And then talk about what you actually think you need your data for, and try to understand that maybe you're producing synthetic data for specific things. Maybe the synthetic data that you actually are producing will work for that, but it probably won't work for other things. So it's not going to be a one-off and solve it all. Oh. Yeah, sorry. Put in this slide just to show you how we're actually working right now with the Swedish National Data Service. So I don't know, many of you are working sort of on this like interface between companies, industry, and the academy. We're working with them and their data repositories to think through what sort of documentation they need to require from people depositing with them. If you have questions from your own practices with synthetic data, we're really happy to talk with you about what sort of things you might want to be thinking about in terms of labeling your synthetic data as well. And just a final thought. So we were going through the literature on feminist technoscience, and there's this like great quote that from one of the big names in the field, Judy Weichmann. She's been doing work with technology and gender since the 1990s, and she's like, well, algorithmic bias is not solely the product of unconscious sexism or racism, nor bad training data, but the end result of a technoculture that has systematically excluded women and people from marginalized groups from positions of leadership and power. Which is true, but incredibly negative. So maybe on the 8th of March event here, we could change it around and just say, including women and marginalized groups in positions of leadership and power is actually a first really good step to address this. I think that in general. I specifically think it in terms of how we're going to be thinking about data and the way we represent our world. So it's really important. Thank you. I think that was everything we've got. Yes. Oh, thank you. We thank our funders too. Thanks.
Let's see if yes, we got sound. Thank you so much, Erica and Sagi. And you did very well with the time. So we have lots of time for questions. And since we have some people watching online, when you ask a question, we want you to talk in the microphone. So me and Julia will run around with these. But we have questions, right? Hands up. Who wants to start? Very good.
Hello, thank you so much for a fantastic talk. So I'm not a tech person, but although I think I could understand what you said, and I think this was so extremely interesting, and I think it sort of mirrors the ongoing discussion of DEI that we have had in the, for years and years. So, but now also coming into the data perspective. And that I think is very interesting. But my question is, to what extent is this known within the university? So, is this something that is taught to the engineers of the future? And I'm also interested to know if there's also, you mentioned some kind of quality system or something that you are working on or together with. Is this also a wider scope? Are there discussions on maybe an overall, like an European directive level or something? Like how will this impact the laws and regulations of the future? Because this is so important. If you have any input on that.
Sagi, do you want to say a little bit about like how the tech people doing the research know? Because I think it's fairly well known.
It's a relatively new thing compared to other concepts in tech. But since 2017 the problem of fairness and bias started to become more important, and more people are working on it research-wise. At university level, still, I don't think there are that many courses that they will teach this to students. Here and there I see some courses popping up about bias, or they have a section of bias and fairness in machine learning, but it's very rare still. I don't think they will talk about it in the tech that much. They know that the bias is an issue, and no one wants to create bias intentionally, of course. But we don't look at these different aspects, and it's a very complex problem, because something that is fair in one definition, is it fair in another definition? If we make things fair for one group, it might be unfair for the other group. So it's a very complex problem, but it's very important to be addressed and think about it for the problem that we have, what kind of costs we are willing to give, and what is important. But unfortunately, not that much is talked about on educational level.
And I can jump in there too with like just one thing that we're doing at Linköping University, which is fairly new, is that there is one engineering degree program with 30 students each year who has required a course on gender and diversity for application development now for the last 4 years. So this is one of the engineering courses has that as a requirement at the undergraduate level, and it was maybe not expected, but quite a success as a course. So the technical faculty actually asked us, it's gender studies that's holding that course, asked us to come back and develop an elective too. So now there's an elective for all undergraduates at Linköping University taking the engineering courses that they can take and study these things. And we do a lot of work around specifically the relationship between representation, representative data, what is data, and the tech development in those courses. And then just last year, they started up a required course for the PhD students at Linköping University's technical faculty that has a module on this. And I have to teach it. I have the privilege of teaching it. So the students get this. They get a lot more, but they get this as well. So Linköping University is making big strides there, I would say. But I think Sagi's right. In a lot of universities, it's not really taught because it's a very different question than the normal things that we think are involved in tech development and an engineering degree program. So there's not lots of it. At the European level, so this was an interesting question because last fall, Sagi and I took this research and decided to think, well, what is actually happening out there with synthetic data? And we sent out a survey to, I think we did 22 different data repositories and asked them specifically, how are you addressing these particular aspects of synthetic data when you receive synthetic data sets in your repository? And across the board, the biggest answer that we got was this. So I thought, okay, that says a lot, and it's totally okay. Synthetic data is very new. It's very new, I understand. And especially the type of synthetic data we were talking about here, which is structured data, is also very new, and it's not so easy to see what's happening in it. Like I showed you these visualizations, and I still talked you through it, but it wasn't just the numbers in an Excel sheet, right? I mean, it's not so easy. Luckily, the Swedish National Data Service came back to us and we're like, no, nothing. But we're redoing our READMEs anyway. Why don't you just work with us a little bit? So we had a series of interviews and workshops with their tech team that's in charge of metadata and READMEs. And we've put together a whole new documentation process for their synthetic data sets with them, partnering with them, and then also written a policy document that's coming out now with the AI Policy Lab in Umeå. And once that's out, we're going to go out and start talking to the other repositories that just had the giant question mark, because we actually think this is extremely important. It needs to be brought up. So any suggestions on whom we should talk to, I will gladly take afterwards.
Thank you. Anyone else?
Thank you. Very interesting seminar, and of course we all engage in this question. I was wondering a little bit about the geopolitical situation and the open research bases that we have around the world that are in some aspects starting to close down. How will this affect synthetic data and what we will see in the future when using it in technical development?
Right. So, okay. One thing right away, I mean, we were working on this project during the last year, and I imposed my vocabulary onto the things that we were seeing, these weird shifts and glitches in the correlations between the different attributes in the data set. And I was like, oh, we should call it intersectional hallucinations and intersectional fidelities. And we've published a couple of papers on that now. And we now sit in a world where the US no longer uses the term intersectionality, and it's forbidden to apply for research money to talk about intersectionality. Yeah, so I don't know what that's going to do. Maybe we might have to change that term to inter-attribute correlations, and luckily I've been in conversation with my funders, our funders who are Swedish funders, and I've asked them specifically, should I be thinking about a new term for this? And their answer so far has been like, no, what the fuck? So luckily that is like, so far we're still there. But I think that, I say that and we laugh at the same time as I have another research project that has collaborators from the US in it. And that project has received a Zoom call where we were asked to specifically remove their names and their collaborations and not mention that we collaborate with them in any way. Because they're no longer allowed to collaborate around issues like this. So I don't know. I think it's a real issue. And I know that there are people who are talking about some of the repositories like Archive and GitHub that receive federal funding or are in some ways threatened too. So yeah, I don't know. You probably know better than I do. You probably have. What do you think?
Just the perspective is, of course, that if we stop collaborating on a global level when it comes to research and innovation, we will go backwards. We will not go forward. And so I'm a bit concerned. I guess we all are. But in that sense, I also would like to once again stress the important work that you do. And I'm very happy to hear that the Swedish funders are right behind you, and so are all of us, I think. So thank you very much.
Thank you.
Do we have any more questions in the room?
Sorry, so a question more on the technical side of the thing. For the graphs you showed before, where the data sets, you had the one case, was it with a female husband? Was that it? And then this got blown up in the training data. My understanding was that you more so see it like decrease, right? These edge cases. Was that just some effect of the training process you used for the GAN or such, or?
So the majority of that data set are male, and that links into other attributes as well, and that was the reason for it.
That makes perfect sense. Thank you very much.
Anyone else?
Yeah, first of all, thank you very much for the good presentation. A little bit about bias mitigation and inclusion. Do you use some kind of tool, with the software which is recognize these signals, and how does it work actually?
To see the biases, you mean?
Yes. In both techniques.
Yeah.
Yes.
So the bias can come in different ways. It starts from the data, the model, and the output of the model. And all of them needs to be processed. What we focused on was mostly on the data and the data that was generated by the model. And then we also focus, if we use this data with any machine learning model, how the bias would be propagated there too. And we have developed some visual analytic tools to be able to check the intersectionality up to 4 axes and look at the data points and see where the hallucinations are happening, where the data fidelity is good, to be able to assess this better. We are mostly using those visual analytics tools and statistical measures to understand where the distributions are different.
So inputs are in two sides. Is the bias mitigation and the training data, Right.
You need to know where the bias is, and then you can put constraint on the model to be able to remove that bias. And you can define in what way you want to remove the bias. Do you want the distributions of two groups to be equal, or you want to remove the dependency of the distribution that the model learned from this gender perspective, for example. You don't want the model to learn about gender. You want to separate that. And there are different ways to do that.
All right. Okay. Thank you.
Do we have one final question? Then I'm going to ask one. Because thank you very much for this presentation. I think it was an eye-opener for many of us. For me, the most things I've heard about synthetic data is that it's going to save us. It's going to make everything so much more effective. So thank you for making it a bit more complex. What would you think is the worst place to use synthetic data right now?
First of all, I think we have to understand that synthetic data is many different things and still the same thing, but it's many different things, right? Like in terms of uses, we have lots of image-based computer vision use for synthetic data, and it seems to be working pretty well in certain situations and certain domains. And we have ChatGPT. Every time you use that, it's spouting out synthetic data. Some people think that works great too. My students especially seem to think it works really great. I don't know. And then we have structured data like this that maybe is sometimes going to do what you want as well as too. I don't know. I tend to be the really negative one in these conversations, and Sagi tends to be the really good one. So let's ask the positive one. Let's ask Sagi. Where do you think?
But that was the negative.
Yeah, it was the negative one, and I'm like, just never use it, never.
The worst and the best.
Yeah. What do you think is but what do you think is the worst use for it?
I don't think it can fully replace the real data. It can be used as an augmentation tool to create different variations. It doesn't create new data. It creates some variations, and so that the model sees some variation and doesn't overfit to one certain thing. So that's the good way to use it. And in the case of facial recognition algorithms, it wasn't able to detect dark-skinned people, but now, because of this synthetic data and the variations that they could create, now the models are working better. So I think that as a data augmentation is a great tool. Sometimes if you can guarantee some privacy, which I'm a bit skeptical about that still, you can also use it to prevent the sensitive information to be leaked, and use that. But I heard some people are trying to test different models that are online. They don't want to upload their own data set, but they still want to know how it works on their data set. So they want to create some synthetic data to be able to rapidly test, because now every day there's a new model coming, and you cannot install everything on your local system, wait for it and see if everything is working. So for testing could be good too.
But I think the Sagi's answer there points to a really interesting point about synthetic data, is that, and this is not just synthetic data, but AI in general. Every time we hear about AI and people are talking about the changes and the way it's going to change our world for the better or the worse, depending who it is, it always seems to be in a conversation where the AI or the synthetic data or the machine learning algorithms are given the agency to do that, where they are given the agency to make our world better or to call forth a dystopia. And I think from the social sciences and our studies of technology and society and the entanglements that they've had forever, historically, we see very clearly that technology doesn't do things. We do things with technology, and we have to own the goals of that technology too. And if we don't own it and don't actively take control of how we're going to be using it, we're still not making an objective, neutral world from technology. We're just allowing other ways of doing it to take the fore. So I think that's basically the main takeaway I think we would like you to bring home from this, is that also, yes, even with like an Excel sheet on steroids. You have to know what's in there, and you have to actively and consciously think about how you're using it, for what purposes, and what values and representations you're putting out there, and which ones you're hallucinating around. Because you have to take responsibility for that. Oh God, I sound like that feminist killjoy. But
we like that feminist. Thank you so much. If we don't have any more questions, then we'll just okay.
Quick question. Yes. So thank you for the presentation. Like whenever I think about this gender bias or like even in the bias in the synthetic data, the first thing that comes to my mind is gaming industry. So and the toys that they make for kids, the kids for different ages. Whenever I see it, bias is so real because it's all the games that you play. It mostly represent men, and the toys that you get to have for women, it's mostly like related to beauty or other kind of things, but not intellectual. How do you think creating these kind of data for games will impact in the future?
Yeah, so that depends on which day you catch me on, right? Like, well, how did I wake up that morning? But I think sometimes about Sagi's example with the facial recognition and the fact that now I can open my phone this way. This is a very powerful and useful tool that they've developed. And there was a real reason to make sure that it would not only work for white men, but that it would work for lots of people. A commercial reason for doing that. There are lots of forces that drive the development of the technology. There was an article in 2018 that came out and showed how biased it was. There have also been articles from the same period that came out and showed how biased certain other machine learning algorithms are, like, for example, the sentencing algorithms that are being used by courts in the US and how racist they are. Those are still in use. They haven't been changed. We've known for 7 years that they're very problematic. We're still using them. This has changed because there are other forces at work behind the adoption and change of the technology. The same will happen with the gaming industry. The same will happen with everything. But we have to be aware of which forces they are, what's driving that development, what's driving that innovation. So on some days, I would say, well, good luck with that. But other days, maybe we can change it together, all of us. We can change it together.
Yes. Ending on a positive note. Let's change it together.
Yeah.
Thank you so much.